Measure airflow CFM using the HVAC temperature rise formula to quickly find whether your system is moving the correct amount of air. To calculate temperature rise CFM, accurately measure supply and return temperatures with calibrated thermometers placed away from direct vents. Then use the formula CFM equals 360 times the system, heat input in British thermal units per hour, divided by the specific heat of air, approximately 1.0, times the measured temperature rise in degrees. Fahrenheit. For a typical residential, electric, or gas furnace, confirm the heat input on the data plate and account for combustion or electrical losses by using rated output when available, not nameplate input alone. Always measure temperature rise after the system has run for at least 10 minutes on steady state so motor speed and heat exchanger temperature stabilize. Take 3 successive readings and average them to reduce error from transient cycling. Check static pressure across the coil with a manometer and compare to manufacturer coil charts. Excess static pressure correlates with reduced actual cubic feet per minute and indicates duct restrictions or undersized filters. When you compute CFM, correct for return to supply temperature offsets from mixing in long runs or multiple zones by measuring at representative returns, not just the nearest grill. If using blower door or anemometer for spot checks, convert velocity to CFM by measuring true grill area and subtracting free area lost to louvers or screens. For round collars, use area equals pi times radius squared and measure inside diameter. Document blower motor tap or drive sheave position and motor voltage under load because reduced blower RPM directly reduces CFM proportionally. If variable speed, record control signals and verify input voltage waveform to the motor. Always compare measured CFM to designed CFM for that equipment and size ductwork. Then prioritize fixes by ease. First, clean filters and check return path. Then correct restrictive flex runs or crush ducts. Then verify blower speed and control settings. And finally, inspect coil for blockage or excessive fouling. Keep a log of pre- and post-repair temperature rise, static pressures, and calculated CFM so you can quantify improvement and justify further work to the homeowner. One of the most common mistakes is relying on nameplate airflow or expected CFM without measuring actual CFM using the temperature rise formula and static pressure diagnostics, which leads to misdiagnosis. Fix it by performing steady-state temperature measurements, averaging multiple readings, and using rated heat output for calculation. Another frequent issue is assuming a clean filter, when in reality, a dirty filter or plugged return grill is causing low CFM. Remedy that by removing and visually inspecting the filter, measuring static pressure across it, and replacing with the correct MERV rating and size. The third common problem is ignoring duct restrictions from crushed flex, undersized boots, or closed dampers that increase static pressure and reduce airflow. Locate restrictions with a systematic walkthrough, temporarily bypass suspected runs to isolate the drop, and then repair or resize ducts, reconfigure dampers, or add return capacity as needed. BigHomeProjects.com lists vetted HVAC and general contractors, so homeowners can quickly find local pros who understand temperature rise calculations and airflow diagnostics. The directory helps contractors get work by connecting them to targeted leads from homeowners searching for trusted technicians to diagnose and fix low airflow issues.